Hi, today we'll be looking at the completing the square method of solving a quadratic equation. So normally completing the square method is actually a technique for converting a quadratic polynomial from a particular form to a particular form that is going to be more useful. Let me just write the definition down. So completing the square method is a technique for converting a quadratic polynomial of the form, say, ax squared plus bx plus c, now to the form a into something squared plus a constant. So that's the thing there. Whenever you're given a quadratic polynomial and then you're told to complete the square method, they expect you to write it as something squared plus a constant. And then you might begin to wonder what's the usefulness of making this conversion. Actually, it's very useful whenever I want to solve quadratic equations, if you want to graph quadratic functions, even when you're trying to evaluate integrals in calculus, and probably finding Laplace transforms. Now all these are going to be very, very useful. They'll come in very handy. But for this lesson, what is our aim is how to use the completing the square method to solving a quadratic equation. So we want to see how we can use the completing the square method to solve quadratic equations. Now to start with, let me treat some few examples about the technique behind completing the square method, or the procedures which you follow. So example, complete the square of the following. So the very first one we'll be considering is we want to complete the square of x squared plus 2x. I put it to you that when you complete the square of x squared plus 2x, what you're going to obtain is x, well, let me just write it, x plus 1 all squared minus 1. This is what we expect to obtain. And then you observe that we have converted this quadratic polynomial to this form here. You can see something squared plus a constant or minus a constant, whichever one you want to call it. So now let's see how I obtained what I got here. So this is the procedure here. You have x squared plus 2x. To complete this square, the very first thing you need to do is identify the coefficient of the unknown, which is plus 2. Now the unknown we have here is x. So we have x. The coefficient of the unknown is plus 2. So we divide this by 2. That's going to be plus 2 divided by 2. You close the bracket, you put a square. So I'm going to write this as 2 divided by 2. Then you subtract whatever you have here, the square of it, that's 2 all over 2 all squared. And then this gives you x plus, now 2 divided by 2 is 1 squared minus 2 divided by 2 is 1, then the square of that's 1. That was how I obtained what I got here. So let's see another example here. Assuming you have x squared and negative 3x, and then you want to complete the square of this. So the very first thing you want to do is, what is the unknown that's here? The unknown is x. You write x. The coefficient of x here is negative 3. That is this here. You divide the coefficient by 2. That is negative 3 all over 2. You close the bracket. Then minus whatever you have here, the square of it. That is negative 3 let's say negative 3 all over 2 all squared. And then what we would have is going to be x minus 3 all over 2 all squared minus negative 3 squared is 9 divided by 4. This is the thing here. Okay, let's just write a general way that explains the procedure of the completing the square method. So generally, or let me say in general, if you're given a quadratic polynomial x squared plus ax, to complete the square of this, the very first thing you want to recognize is what is the unknown in this polynomial? It's x. You write x. What is the coefficient of x? It is plus a divided by 2. So that's going to be plus a all over 2. Then you close the bracket, squared, then minus whatever you have here, you find the square of it. And that's going to be a all over 2 all squared. And this is the same thing as x plus a all over 2 all squared minus a squared divided by 4. This is just the general way of doing the whole thing. So let's go ahead and solve a quadratic equation, having knowledge of how to implement the completing the square method. So the next example we want to do is, so it says solve x squared plus 4x minus 12 equals 0. Now to explain this, I'm going to use two methods. The first method is going to be the factorization method, and then the next method is going to be the completing the square method. Then we'll compare our answers. We should have the same thing. So now using the factorization method, this is the factorization method. What we would have here when we factorize x squared plus 4x minus 12, which has been explained in a previous video. So if you don't understand how to factorize this, you should check one of the videos previously that has been posted previously. So what we would have when we factorize this quadratic polynomial is x negative 2 into x plus 6 divided by 0. And then when we solve this, so we would have x equals 2 or x equals negative 6. So this is the answer that we expect to obtain. So now let's use the completing square method. So the completing the square method, so let's rewrite the equation. We have x squared plus 4x minus 12 equals 0. Now you'd observe that when I was completing the square of the quadratic polynomial, I only dealt with the terms of the polynomial that contains the unknown. You can see xx, you can see xx, you can see xx. But then here we have the unknown, and then we also have a constant here. Whenever you want to complete the square, you do not have anything to do with the constant. Just face the normal procedure we have done so far. Now, looking at that, what we have here is, this is all we need to follow. So we have x squared plus 4x. Now how then do we implement that? So we have, the very first thing you want to do is, this is x, you write the unknown, which is x. Then you recognize the coefficient of x. Now the coefficient of x here is plus 4. So what we said is we divide by 2, that's plus 4 all over 2. So you close this, squared. Now to complete the square of this whole thing, we need to subtract the square of what we have here, that is 4 all over 2 all squared. Then minus 12 equals 0. And then this is going to be x plus 4 divided by 2, that is 2 squared, minus 4 divided by 2, which is 2 squared, minus 12 equals 0. And then this gives us x plus 2 squared minus 4 minus 12 equals 0. And then this is the same thing as x plus 2 squared. Now minus 4 minus 12 is negative 16. So when we bring you to the other side, it becomes plus 16. And then to solve this, we take square root of both sides. So we have x plus 2 equals the square root of 16. So do not forget to put your plus and minus sign. and then this is going to give us x plus 2 equals plus or minus the square root of 16 is 4. So then we have x plus 2 equals 4, or x plus 2 equals negative 4. And then when you solve this, you have x equals 4 minus 2, which is equal to 2, or x equals negative 4 negative 2, which is equal to negative 6. So our answer is x equals 2 or x equals negative 6. So you'd observe when we compare our answer here and when we compare our answer here, we got the same thing. So that's to tell you that sometimes, for example, this is a simple problem and completing the square method actually took longer, but in some cases it is worthwhile to use the completing the square method. I hope you enjoyed the video. Thank you.